ABCD is a rectangle. P, Q and R are the midpoints of BC, CD and DA. So we have a rectangle. Let's say A, B, C and D. Okay. And P, Q, R are the midpoints of BC. So P is midpoint of BC, Q and R. Okay. We have these three midpoints. The points S lies on the line QR in such a way that SR is to QS is 1:3. There is another point S at QR. So if we join QR, the point is at S. The point S is at QR such that SR is to QR. Okay, so point S is somewhere here. Okay, let's say this is the point S, and this is 1:3. The ratio of area of triangle APS. Okay, we have triangle APS and rectangle ABCD is what? Okay, so we need to find out the area of triangle APS. Okay, that is the challenging part in this question. So see, P is a midpoint of BC. Okay, so because this triangle APS is bit irregular, we don't have a proper way to get the area of this triangle. Okay, so let's join PQ. Okay, if we join PQ, I see few rectangles. Let's name them. This is one. This is rectangle number. Sorry, triangle 1, triangle 2. Okay, one is ABP. Triangle 2 is PQC. This is triangle 3, SQP, and QDR is triangle 4, and ARS is triangle 5. So from area of rectangle ABCD, if we subtract the area of 1, 2, 3, 4 and 5, we'll get the area of triangle APS, right? That is the only way I see here. So now we need to find out the area of all these triangles. So area of triangle 1. See, AP, imagine we have AC joined, okay. So if AC is joined, then area of triangle ABC will be half of this area of this rectangle, and let's say the area of entire rectangle is A, okay. Capital A is the area of this rectangle. So if we join AC, triangle ABC will be half of this area, and because P is midpoint of BC, AP will bisect that into 2 equal half, right? So APB is half of triangle ABC, right? We can say that. So I think one simple thing which we are going to use in multiple, we are going to use for multiple triangles is, let's say we have a triangle, okay, of any irregular shape. And then if you know the area of this triangle, let's say the area of this triangle is T, and there is any random line, let's say this line is dividing this triangle into, let's say this is 1/3 and this is 2/3, okay. So the point at which this line is dividing the triangle will also divide the area in same ratio, right? So if this point is dividing this line into 1:3 and 2:3, then area will also be divided in the same way. So area of this smaller triangle will be T/3 and area of this triangle will be 2T/3, right? So same concept we are going to apply here, just that we need to see which triangle can be extracted from where. So I think triangle 1 APB is half of ABC, and ABC is what? It's half of A, right? ABC, because AC will be diagonal. So it will be half of A, or I can say it is 1/4 of A. So we have got triangle 1. Triangle 2 is PQC. So again, I see if we join PD, okay. So if we join PD, then PD will divide this entire rectangle into 1/4, okay. So think it like this way: if we join PR PR is dividing into half, PD will divide into further half, that is 1 by 4th. And if we see PQ, it will divide PD into 2 equal half. So PD is, so PQ will divide this entire rectangle into 8 equal parts, right? So we can say that, if you want, I'll explain it for this case, for triangle 2, and for next triangles I'll just directly write it. So area of triangle 2 is half of, and anyway if you are joining two midpoints of sides of a rectangle, this will divide into 1/4. Okay, you can directly also write this, but if you are not getting that, see here. So area of triangle 2 will be half into area of triangle PDC. Okay, and triangle PDC is half of rectangle PRDC, so that way you can get it. So PDC is 1 by 2 into, and PDC is 1 by 4th of A, so we have 1 by 8A. Okay, and now we have triangle 3. So triangle 3 is okay. So here imagine we are joining PR, okay. So if we join PR, then triangle PQR, okay. So this rectangle PRDC is half of area, and triangle PQR will be 1 by 4th of this area, because this is 1 by 4th, sorry, triangle 2 is 1 by 8th, this is 1 by 8th, so this should be 1 by 4th, okay. So triangle PQR is 1 by 4th of A, okay. And now see, in triangle PQR, this line QR is divided into ratio of 1:3. That means this portion is dividing the entire triangle into 3 by 4th, right? So from here we see the area of triangle 3 will be 1 by 4th of A into 3 by 4th. Okay, so we can write it as 3 by 16A. Okay, so PQR I just wrote to compare this. Otherwise area of triangle 3 is 3 by 16A. Okay, and area of triangle 4. So area of triangle 4 is again you can imagine it is being divided into 1 by 8. Similarly what we did for triangle 2, similarly triangle 4 will also be 1 by 8th of A. Okay, and now we have triangle 5. So for triangle 5, if you see, if we join AQ, okay, so okay, you can start from here. If we join AC will divide the rectangle into 2 equal half, okay, and then if we join AQ, then AQ will be 1 by 4th of this area. So triangle AQR, and this triangle 4 is already 1 by 4th, so triangle AQR, okay, triangle AQR is also 1 by 4, and if triangle AQR is 1 by 4 and this line QR is dividing the entire triangle, so I am talking about triangle AQR, so triangle AQR is 1 by 4th A, and SR is dividing the RQ into 1:4 ratio. So area of triangle ARS, which is triangle 5, will be 1 by 4th of this, right? So then area of triangle 5 would be 1 by 16A. Okay, so this was part of this only. AQR is 1 by 4th. So triangle 5 would be 1 by 16. So now we have got area of all these triangles, and if we get sum of all these, then we'll have 1, 2, 3, 4, 5. So we'll have 1 by 4 plus 1 by 8 plus 3 by 16 plus 1 by 8 plus 1 by 16. Okay, so let's do it here. So we have 1 by 4 plus 1 by 8 plus 3 by 16 plus 1 by 8 plus 1 by 16, okay, into A. So this is sum of areas of all these 5 triangles, and from area of ABCD, if we subtract this, then we'll get the area of triangle APS, okay. So this will be I think I did a mistake here. 1 by 16 AQR, okay. See, AQR will be so AQR is half of AQD and AQD is half of ACD, okay. So ACD is half of A, okay. This is ACD, and so this is ACD, okay, triangle ACD. And if we further divide it by 2, then we'll get AQD. So if we divide it by 2, then this is AQD. And then if we get AQD, then if we again divide by half, then we'll get AQR, okay. So this is AQR now. And then now AQR is being divided by RS into 1:3. So this will be 1/4, right? So total is 1:3. So this is 1/4, okay. So now if you multiply this by 1/4, then we'll get area of triangle ARS, okay. So now this entire thing is giving the area of ARS. So it will be 4, 8, 16, 32. So this is 1 by 32A, okay. So here we'll have 1 by 32A. So if you take LCM, it will be 32 and 8 plus 4 plus 6 plus 4 plus 1, okay. So we have 12, 18 to 22 and 23. So we have 23 by 32. So 23 by 32 is area of these 5 triangles, the smaller triangles, 1, 2, 3, 4, 5, okay. So then area of triangle APS will be area of rectangle minus sum of all these 5 triangles, so which is A minus 23 by 32A, which will be equals to 9 by 32. 9 by 32A, okay. So ratio of area of this triangle to area of rectangle will be triangle APS by rectangle ABCD, which is 9 by 32A by A. So A will get cancelled. So the ratio is 9:32. Okay. But if you see in the options, 9 by 32 is not matching. But if you carefully look again, you will see some of the options are not normalized. Okay. They can be further normalized. And if you multiply this by 4 into 4, you will see 36 by 128, which is in the option. So 36 by 128 is the correct answer. Okay.